All right. What is up, Rust family? We're here tonight with another episode of the Learn Rust live stream. We're just coming off finishing the book. Yep, we did it. It took a while, but we did it. Every single chapter, 1 through 20, we built the web server. We're going to be adding to the web server probably next week. But tonight, I want to do something a little different. Take maybe a little break from doing the book and kind of do like a review of the journey so far, talk about what we did, what chapters. I'm going to talk about what chapters I liked. Obviously, it's all going to be subjective, but what chapters I enjoyed, what I like so far about Rust compared to other languages that I've used, what I think we can do going forward. We'll talk about the book. We'll talk about the Rust links exercise we did. We'll talk about the potential future things we can do, like one of them is exorcism.io we might do. We're going to be adding to that web server and probably following some of the cues that they left at the end of the book for us to try out. Trying out some crates is going to be a big one, right? We learned about crates, so we're going to try to pull in some other ones. And then building some small projects. We've got some awesome comments in the chat on YouTube requesting some projects, so maybe we'll start there. But if you do have any ideas for other things we can build with Rust, feel free to put them in the comment section below if you're on YouTube, or toss them in the chat if you're watching live on Twitch. It's been really, really fun. And yeah, so today is going to be mostly just chatting. We're going to chat about the book. I'll talk about, like I said, what I enjoyed, some of the chapters I enjoyed, some of the things I'm looking forward to doing with Rust. I'll compare it to some of the languages I've been using. And we'll talk about what's coming up next for the stream, right? We're going to keep going. We're going to keep doing Rust. Maybe we'll pull in some other language stuff. As many of you may know, I work with other languages day to day, JavaScript, Elixir, Python. So maybe we'll do some more of that. But don't worry, there's definitely more Rust in store. So let's jump in and let's do a quick recap of where we've been. So if you missed any of it, it's all up on YouTube. So you can see this is where we started. We started out with chapter 1. Whew, look at that. Young Tom. Nah, it's only a few months ago. We started out in chapter 1. We made it all the way through. We did a little one-off running on Docker. I'll probably continue with that. We did the Rust links exercises, so we'll go over those in a second. We'll talk about the fun exercises that we did. We did it all, every single chapter of the book, and we ended it 2 weeks ago. We took a week off last week, but 2 weeks ago we did the finale. It was a longer episode. I think it was like 3 hours. So we did a 3-hour stream. We built a web server in Rust, a multi-threaded web server. We followed along there. And there's some cues at the end of it, or some prompts, I should say. Some prompts at the end of it for suggestions on what we can add to that. So we'll definitely be picking that up probably next week. But again, today I'm just going to kind of recap. We're going to go through some of the chapters of the book that I enjoyed. We'll talk about some of the topics, some of the things so far that I've been liking in Rust. I'm excited. Again, follow on Twitter for updates of when you go live. Of when I go live. Maybe you go live. But follow that on Twitter there. Again, the repo for the code that we've been writing is all here. So you have the Learn Rust Live. You can see we put chapter 20 up there. It's all here. Go here. You can follow. You can start. Whatever you want. You can just use it as a reference. You could have your own repo. But whatever you want, it's all here. And we'll probably be looking at this today. And the book. Of course, this is the book we finished, right? So I always give a shout out before these episodes. Shout out to Steve Klobnik and Carol Nichols, the authors of the book, and anyone from the Rust community who contributed. Got to give a shout out. Excuse me, sorry. Need a little water. You got to give that shout out. So we've had an amazing time, or I've had an amazing time, I hope you have, going through the book, and it's been super helpful. And today, this is what we're going to be reviewing, right? We're going to talk about what we liked. Rustlings we did, so we'll cover that in a minute. Another shout out. I want to thank everyone on YouTube who's been subscribing and liking the videos. We've reached over 500 subs. May not be a lot in general YouTube standards, but for myself, for someone who's just doing this once a week and just posting their stream up there, it's been awesome to see how many subscribers and how many people are interested in these videos. The views have been going up, which has been great. So if you like what you see, again, like and subscribe. Recommend some content. What'd I say? Comment? Recommend some content. Put some comments in the chat. Tell me what you'd like to see. I'm happy to hear some requests. We'll definitely, like I said, be doing more Rust. We'll probably revisit that web server, pull it down some crates, and try doing stuff with that. Other languages, anything folks are interested in. Otherwise, what I'm going to do is just code, right? Every week I'll do something fun and different that I want to mess around with. I'll live stream it, and then I'll post it up on YouTube. But you have to shout it out. Thank you so much. It's been awesome. 505 subscribers. Look at that. It's small in YouTube standards, but big for me, right? I wasn't even planning on getting more than 5. 5 close friends that I have, all 5 of them. No, these aren't, I don't know most of these people personally. I will get to know all of you through your comments. So thank you for that. That's been awesome. All right. So let's talk about Rust. Let's talk about the journey so far. So we started this book, and the cool thing we did in the beginning, right, was they jumped us right in. We did the installation, whatever, but they jumped us right into the hello world. And right off the bat, it seemed pretty straightforward, right? Print, nothing too fancy. And then we started getting a little more into the environment, like the build tooling, cargo. So I want to talk about cargo for a minute. So I'm going to pull that up because that's well, not just cargo, but Rust. Apparently it's a post-apocalyptic movie. That's awesome. Cargo Rust. Ooh. We can talk about it here. We can talk about crates. But anyway, what I love about cargo, let me just look at it here. What I love about cargo is it's awesome to have build tooling around your language. So I'm coming from having a lot of experience in Java, right? Maybe some experience in, not a lot of experience in Java, JavaScript. I have some experience in Java, very little. A lot of experience in JavaScript. A lot of experience, kind of a good amount of experience in Python. Done some Python. Done a bunch of Elixir recently. You've heard me talk about that a lot. I'll probably talk about that more because I'm really, really enjoying that language. I've done languages like Elm. I've written very little C. What else have I written? A few other things. But basically, most of my experience is in JavaScript and the JavaScript ecosystem. And in JavaScript, we now have NPM for managing packages, but we don't have anything for scaffolding out new applications. Of course, there's third-party things, right? There's Create React Native app for creating React Native apps, and there's CLI tools for things like Angular and Vue. But having it built into the language and having it be a set thing has been really cool. So Cargo has been awesome. And we use Cargo. We used it a bunch. So every time, let me see if I can pull this up. Every time we created a new repo, right? Or every time we created a new, let me pull this up here, a new project, or anytime I did a new chapter, I used Cargo. And what was great about Cargo and what I really liked about it is it gives you everything you need. So here's like an example, just Cargo project that we built out. So you have your source folder, there's a binary crate or a library crate. So we had our main like source file. We had our TOML, which kind of describes our dependencies. That was super cool. The lock file. But it was just awesome, and it gives you all the tooling. And it also is what lets us build and what lets us run and what lets us test. So that was super cool. Coming from something like JavaScript, right? To do that, I have to pull in libraries. And so some may say, oh, it's nice, not, you don't get everything out of the box. You have to pull in things. But I really enjoy Cargo because it's built for the language. It's built for the language. It has the compiler. It has the checker. It leverages everything for you. And so that's something I've really, really enjoyed with Rust, was just using Cargo. It's super easy, super intuitive. So that was really fantastic. Next, we actually did the guessing game. So the guessing game was cool because I like when books dive right in, show a bunch of concepts, and then kind of like elaborate on them later. And I think the book did a great job of just jumping in and having us use the guessing game. Here's why I really like the guessing game. So if you've ever done a hello world for any other language, it's usually something similar, right? You're reading input from the user. Sometimes they have you just jump right in and read it from a file, like in Node. I know a few Node tutorials have used the file system API. But it was super cool jumping in, taking user input, and building something kind of fun, right? The guessing game was pretty fun. And they did it in some really great steps. So we had processing a line, showing an exception, and we did things the long way. And then we saw later how to make them better, right? And we learned about things as we went along. So we learned about basically reading input, and then one of my favorite parts about Rust, which we're going to talk about in a second, the result type. So here we can talk about handling failure with the result type. So I really love this. This is one of the things I love about Rust. I actually like this about a lot of strongly typed languages. If you've heard me mention Elm, Elm's a language that I work with a lot, Elixir, mostly for side projects, nothing professional. But what I love about Elm is Elm has something similar. And why I like the result type is it's a way to indicate that something can fail without like it being something throws and catches in JavaScript. It's a way to wrap something in a potential that, you know, it may or may not work. And why I like that, right? The reason I like that is it forces you as a developer to handle both scenarios. Often, and you know, I think we're all probably guilty of this. I'm sure most people, you know, handle this appropriately, but I am guilty of this at least. In JavaScript, for example, when I make a request to a server or I do something that may fail, I usually just handle the happy path, right? I'll do a try with an async await, I'll make a request. You know, obviously in real production apps, I do handle the errors, but like generally when I'm just messing around, I'll often just code the happy path first. And the problem is sometimes I'll forget to go back and do that error path, right? I'll forget to handle that other part of it. And with the result type, you have to, right? Your code won't compile if you don't handle both scenarios. So it kind of forces you to think in a way of like creating a safety harness around that result type and making sure that everything's handled. It is a little more work up front, but the benefits are that you're guaranteeing you're thinking about both situations. And I find when you think about both of those situations up front, you tend to write better code because your code reflects both scenarios that are possible. Instead of just reflecting the happy path and making the error path an afterthought, you're really coding with the expectation that, hey, this can go right or this can go wrong. And we even learned about, you know, instead of using, we can use like the question mark, right? So if it proceeds, we continue with the line, otherwise we panic. So we learned how to use the result type to our basically best interest, right? We can figure out to our advantage. So we can figure out, do we want to continue this program? Do we want to panic or do we want to handle the error? Maybe it's an error that we're okay with, right? So the result type was something I was super interested in. So I'm going to pull up some code and we'll take a look at some of the places we used it. So I'll pull up the guessing game and we'll see some examples here. We also, remember we adjusted our guessing game. We broke things out. That was kind of cool. So we had our main program and we delegated it out to some library functions. So let's take a look at one of our result types. So here we had trimming of the guess. So we took input from the reader. It was their guess, it was their number, and we trimmed it. And again, that could pass or that could fail. And so we handle that. And in this case, we didn't just use the question mark and move on to the next line if it was good. We actually did something that was useful for the user in the error case. So in our OK case, you know, we processed it. We had our value, right? We returned our value. If there was an error, right? If there was an error parsing the guess, right? We printed it. So we did something useful with the error, and the result type let us do that. It gives us both scenarios and lets us write our code up front thinking about both of those. So this kind of thing is what I really like in typed languages, is that notion of a maybe type, right? Something similar to this is the option type, which is the next thing I want to talk about that I really like. So let me see if I can find an instance where we're using an option. There's a bunch of places. We use it all over. Let's look for an early chapter. Let's see. Not that one. Let's try to find a more basic one. Favorite color here. So favorite color. This is an example of the option type. So the option type, like the result type, kind of encapsulates two types within it, right? You can think of it as almost like a struct, right? The struct that has two values. So the value of option can either be the thing, right? Some type, in this case a string slice, so some string slice, or none. And so the option, again, this is another situation where it makes you handle the two different code paths. There's the code path where there is a value present in that option, and there's the code path where there's no value present. And so it lets you kind of model things in a way that I often wish I had in JavaScript. To give you an example, if any of you have ever written React or done JavaScript, one of the things we deal with are components. And components receive properties. And they also have state that they manipulate, right? And a lot of times you start out, you have something that has to fetch from a server, right? It has to go to a server to get some data. Let's say it goes to a server to get a list of users. Well, you initially start out with no users, right? So you have to go get those users. And so you have to make a decision. How do I want to model that? Do I want to start with the initial value being an empty array of no users? Or do I want to start out with null? And null is always weird in JavaScript, because if you try to model that with a type with TypeScript, your type would then be a list of users. Let's just say it's strings. You would say our list of users is an array of strings or null. So it's like it could be this thing or this thing. So it's almost like you can model an option, but it's a little awkward. And the other reason it's awkward is if you decide to go with an empty array, then you have to figure out, well, how do I know when I'm in a situation where I haven't yet fetched my users versus a situation where I have and there really were no users, so I get an empty array. And then you end up introducing a third thing like is fetching or is loading to indicate that you haven't tried yet. With option, what's really nice is you can say, hey, this value is either something, it's either an array of strings or none, right? And it's one or the other, and it's a nice way to model it. And anytime, this is the key thing, anytime you use that value or deal with that value, you're going to have to check, do I have something here or do I not? Versus JavaScript, where you could try to manipulate that list of users as if it was an array, and if it is in fact null, well, you can't call map on it, you can't call your array functions on it, so you have to have a check there. And your code won't tell you that at compile time, right? Unless you're using something like TypeScript where you're actually enforcing these things, you won't catch that. With Rust, though, with the option type and similar to the result type, you catch those earlier on at compile time, and it forces you to handle them. But really, I really like the way it lets you model data. So that's really cool. So that's definitely something I like about Rust, for sure. Let's go back. Let's see what else we talked about. Excuse me. So the other things we did, we learned about printing, the debugger, how to print, how to format strings, general stuff like that. We also pulled in a crate. We pulled in a random crate. And I want to talk about this a bit because the crates I find super cool. So I'm familiar with pulling in dependencies. In JavaScript, we have NPM, right? In Python, we have pip. In Elixir, we have mix in our mix dependencies that we put in our hex file, right? So we import dependencies there. So a lot of languages have this. So it's not like a rare thing, but it's very easy to do in Rust. And for a lot of the other languages, it took a while to get there, but Rust comes right out of the box with a really great package system. So it's cargo and we have crates. And we see that we have our cargo toml file, and that's where we're specifying. Let me pull up a cargo toml, for example. Let's go in the guessing game. You have your dependencies and your random. Also, while we're here, might as well touch on the fact that cargo went with toml, right? It went with toml for a its dependency file, right? It's like package descriptor. Other languages have JSON, right? We have our package.json in JavaScript. We have for like serverless, we have like serverless YAML file. So often you'll see YAML used. YAML, I would say YAML and JSON are probably the most common, but toml was introduced to us by Rust. I had never seen it before. Maybe you had. But toml is Tom's obvious markup language, Tom's obvious minimal language. So this was really cool. It's I think it's, we could probably, it doesn't have to just be Rust. You can use this anywhere. Anywhere you'd use a YAML or a JSON, you could probably switch this out if you're writing something to use those file types. But it's pretty cool. It's very easy to read, right? You have your header and you have your values. And what I like about it is it's key value, key equals value. So it's very straightforward, and the nesting is pretty straightforward as well. And then lists are just lists, right? Arrays, what we're used to. I know YAML, we have indent and then dash. JSON, JSON, it's curlies. It looks like more like a JavaScript object. And they talk about other different traits, right? JSON, YAML, they talk about that here and they compare it. So this was super cool. First time I had used toml, and I like it. I mean, I think it's really cool. Very straightforward and easy to use. So that was awesome. So yeah, I really liked cargo. I think what it does with the crates, it makes it really easy for packages. I know that with NPM in JavaScript, it's not as, you don't have cargo or crates, so you're dealing with, in the JavaScript world, you're like, do I use yarn? Do I use NPM? And a lot of it's subject to the author of that package or whatever, but in Rust, it seems like we've settled on a single package manager, cargo in this case, and it works really well. Same thing in Python, right? Python, we have pip, which is pretty standard right now, I think. And then other languages, Ruby, right? You have your gem files. So it's nice to have dependencies and be able to declare them. So that was cool. We got to see how that worked. Another thing we did in the guessing game, let's see. We did some comparisons. So this is when we started to use traits, right? And we also learned how to import things. So one thing, the import syntax is easy enough, but it's not as, in my mind, friendly looking as something like I would see in Python or JavaScript. I like the import blank from blank because you kind of know where it's come from. Whereas here they've simplified it, right? So it's just use this, and you know that ordering comes from standard compare. But it's the shorthand that sometimes can be a little confusing, right? Like standard compare. I know that this means standard compare because we talked about it, but if you don't know these off the top of your head, you do have to look them up, which is fine. But it's this was a little bit weird to see at first. And they even mentioned like you won't know what functions to use. You just sometimes have to look it up, like what's in the standard library. So I think once we mess with Rust more, we'll figure out what's in the standard library, what's a crate. But yeah, this was a little odd. And also the way that we can specify multiple packages from the same source, that syntax, was a little bit confusing at first. I'm sure it gets easier as you write more code, just like anything, right? JavaScript's confusing too. You have your default export versus your regular exports. Python, you can do similar things. I think Python has one of the easier import syntaxes, but yeah, that was something that was interesting to me. What else did we do? So the IO for reading was super easy. Loved that. Oh, this is an obvious one. We have to talk about like mutability, right? So one thing that Rust has that not every language has, right? Because they're all different, obviously. But there's some languages just let you mutate things, right? And some just don't let you mutate things by default. So for example, in JavaScript, everything is mutable, right? Even when you declare a constant, you technically can change it, but usually your bundler or your compiler will warn you against it if you're using TypeScript or something like that. But you can still modify it, right? And so there's no notion of mutable and immutability. You have to kind of create that notion yourself. And so often we do that in JavaScript. We'll use a library like immutable.js, or we'll be consistent in whenever we manipulate something, we'll create a new version of it, or we'll use functions like map, filter, and reduce that always do return a new value and don't mutate the original list. But in Rust, you need to be upfront, right? So let me look at our code. Let's take a look at our guessing game again. Let's look at our library. We didn't use the library, okay. Guessing game. So let's look at the beginning here. So we declared secret number. It's not mutable, right? So that's not going to change. But here we have something that's mutable. We have our guess, right? And we need to declare that it's mutable so that the compiler knows how to handle memory for it, which makes sense, right? We're dealing with a lower level systems programming language, so it makes sense that we need to know that it's mutable. So this is a little more effort, right, than something like a scripting language, but that's to be expected because we're going to get the benefits of the compiler, and you don't get that with a weakly typed scripting language like JavaScript or Python. They all have their pros and cons, right? And they all have their correct use cases. You have to figure out what's the right tool for the job. But if we're just talking about Rust, it's a little more overhead to do this, but it gives you the benefit of that compiler. So another thing that we talked about, which is different if you've never used a memory managing type programming language, like this is gonna, again, lower level programming languages, systems programming, you wanna deal with memory management. Why? Because you can make your programs, you have more control over the memory they take and the speed, then you get more performance out of them, right? This is gonna be faster than something like Python because it allows you to get lower level and really deal with how you're working with memory. So we had the sense of passing by reference, right? So you can pass a reference to something. And then you can also pass something and you have the borrowing notion. So we're going to kind of get into the next part, but really quick. So you have mutability, immutability. It has to be declared. And we had this ability to pass references to things and dereference things, which gets me into my next topic, which I actually really like. It's a little bit confusing up front, but I really liked it. And that's borrowing, right? Understanding ownership. This concept was something completely different from anything I've seen in JavaScript, Python, Elixir. Like I've mentioned the languages many times. I don't need to anymore. The other languages I've used, right? And if you're new to programming, this might be a little bit weird. But don't worry if you're new to programming. It's just as weird for someone who's not new to programming because it's a new concept. And so ownership was a little bit interesting for me to like initially start with, but then once I got it, I really understood it. And I kind of related it a little bit to JavaScript. JavaScript has this notion of context and where things are, their scope, right? Where things were created and where their life is and where their scope is. And that we call that context. And creating closures, you can manipulate context to create closures and things like that. But with Rust, the reason we have this ownership and borrowing is so that we know when a thing is being used and when we can free up its memory. And this is a really cool concept because I think about it like a book or something, right? If I have a book that I'm reading, I could clone it if it's something simple, and that's like the copy trait, right? If you have something small, you can copy it. But with the book, if I need to pass it to somebody, I would let them borrow it. And that means they have ownership over it at that moment in time. I may ultimately own the book, but now they've borrowed it and they have it, and I don't have it anymore. But I want to, at some point, get it back, right? And so there was this notion of being able to pass a reference to the book, right? Passing a reference, and this way you still take ownership. Whereas if you give the full book, right, then they take ownership. And that's where we saw passing a reference versus not a reference. So I want to go down here a little bit where we can see some of these examples. Actually, I'll just pull it up. I have ownership as a file here. So we have this string, we create a string we call take ownership. Why does it take ownership? It takes ownership because we're not passing a reference, we're passing the full thing. So we're actually saying here, we're giving it to that person. It's like giving the book to that person. And so what it means is once you've given ownership, you no longer have it in this main scope. And that means I can no longer use it here, right? So I'm not able to use S after this take ownership point. And if I try to, it will complain. So that's pretty cool. That's a way to pass ownership. And why is that useful? Well, if this function is done with it, I can safely pass it away. Doesn't matter if my function is done. Just if I'm done with this thing, I can pass it to something else, let them use it, and I know that I don't have to worry about cleaning up its memory. Whoever has ownership will either worry about cleaning up its memory, or when that function ends, if it hasn't passed it somewhere else, it will be cleaned up automatically. So it's a very nice way to handle almost like, there's no garbage collection, right? But it's a nice way to kind of not think about the life cycle of that thing once we're done with it. So, but the caveat that we can no longer use it. So that was giving ownership. Now, we talked about some of the types of variables that are copy. What does that mean? It means the simple ones like integers, right, and characters are copy. They have the copy trait. So when you pass that around, you don't actually end up giving up ownership. It gets copied, and so we can still use X. And we see that here. We can call make a copy. It just takes an integer. We know that integers implement the copy trait. Strings do not, and so I can still use X. Then we talk about, here we call it gives ownership, S1. So what S1 does is this is calling a function that then gives us something back, and it gives us that thing back with ownership. What do I mean by that? Well, we have the gives ownership, some string, we create a string and we pass it here. We're passing it the value, so gives ownership is giving up that ownership, passing it back to our S1, and now we can use that value. So what do I like about ownership? Well, what I like about it is once you see it, it's pretty easy to understand once you've done it, and I think this file kind of illustrates that. I'm definitely going to go back to this file a bunch because it has those examples, but I really like the concept of having control over it when you take ownership, when you give it up. What else do I love about it? The compiler. The compiler is going to tell me, hey, you no longer have access to this. And it's going to tell me what I need to use and when. And the guarantees are what I really like. I guarantee that I'm handling memory in an efficient way. Things are going to get cleaned up as I need them to. And when things go out of scope, they're destroyed, right? And so I only need to think about what's in scope and what I care about. So I thought this concept it's a complicated concept, but it's simpler than having to kind of understand how this all works yourself and managing it yourself. They introduced this borrow thing to give you control, but to make it easy and to make it more difficult to cause problems. In other languages, in C, for example, I always struggled with ownership, references, and pointers, and passing them and dereferencing them. I remember just adding an asterisk to get to get values out. Vortex Manipulator in the chat. Hi, Tom. Glad I can catch a stream, but it's incredibly late. We'll be able to catch this on YouTube. Vortex, absolutely. And do not worry if it's late. I just appreciate you stopping by. Awesome to see you. And yes, it will definitely be up on YouTube. So check it out there. And thanks again for stopping by. Also, if anyone else watch on YouTube, hop in the stream. It's fun. Vortex showed up. But the stream's 9 p.m. to 11 p.m. Eastern time. Today's going to be a shorter one. We'll do like a shorter review. But usually to 11 p.m. Eastern time. And we'll see. Maybe we'll switch it up. But hop in. It's fun. Vortex did it. You can do it too. It's cool. All right. So it gives you that power without being too hard. I remember just popping asterisks on, like I said, to dereference stuff because I didn't know what I was doing with C. I was also a very beginner programmer. I was in school. I was partying a little bit. It's college. But I had trouble with C. I did. Like, C almost turned me off of programming altogether. In fact, Java almost did too. But then I found a little language called JavaScript, which was crazy and wild, but allowed me to do crazy things, and that's exactly what I needed at that time. Vortex, sweet. Have a great stream, and good night. Good night to you too, Vortex. Thank you for stopping by. So yeah, so this took a very difficult, in my mind, what's a very difficult concept, and made it a lot easier. And if this is your first programming language, right? If you're learning Rust for the first time, or not Rust, any programming, like if this is literally your intro to programming, this is something you get from systems programming level languages, right? Lower level. And that's why they're so performant, is these kinds of things. If you don't need that, if you don't need that speed, right? If you don't need that safety, if you don't need a language that can create a binary that can run on any operating system without the language needing to be installed, maybe you don't need Rust, right? And I do want to emphasize that, like, every language has a use. And there's a few things to consider when you're thinking about a language. There's step one. Is it fun to use? Right? That I mean, it's not the best step, right? The best step is it the right program? But like, really, like, if we're coding in this all the time, is it fun to use? Is it enjoyable? Is the syntax easy? Is it simple? Is the tooling great? Is the experience great? That's an important one. The next one is, what is the problem I'm trying to solve? And does this solve it? Can I solve it with this? And can I solve it with this in an easy way? Basically, what I mean by that is, if all you're trying to do is make a request to a web page and spit out the response, and you just want to run it, it doesn't require to be really safe. It doesn't need cross operating system capabilities. It's just going to run on your machine randomly on a script. You could build it in Rust for fun. It'd be cool, but you don't need it, right? You could use something like Python or JavaScript. And that's why Python is very popular. But that's not to say don't learn Rust. It is also very important in my mind to learn Rust because it has a different job, right? And that's why I'm here. That's why I'm learning Rust. I already know a bunch of other languages that I've tried, and I have some idea of what they're good for, but I didn't have that systems programming language. I told you I tried C, and it just wasn't for me. So the lowest level language I have would probably be, I don't even know, like, nothing that runs on the binary level. Maybe the closest I would get is something like, that's really fast, maybe like Erlang or something. I don't know. I don't really actually have any, none of the languages I can think of are going to create binaries that can run on any machine like this. I've done some bash scripting that's good for cross machines, but like, I didn't have a good systems programming language. What do I mean by that? Systems programming meaning low level coding for systems, with the ability to create a binary, right? And that binary can be run on Mac, it can be run on Windows, it can be run on Linux. And so that's a cool benefit, right? So what can you do with Rust, for example, that you couldn't do with Python? Well, with Rust, you can write a script. Let's say you write a script that deletes some files, right, from a file system. You can write that in Rust, create a binary, and run it on Windows, it'll work, and run it on Mac, it'll work. I'm sure there's some caveats, right, to the file systems, but otherwise, if you wanted to do that, you'd have to write a specific Windows script, maybe a bash script for Mac, and then maybe a PowerShell script for Windows, and you have to use some custom APIs to do that. I'm sure there's other scripting languages that obviously work across, but whatever. But it's going to allow you to do that. But the key thing with Rust is it's going to allow you to do that in a safe, performant way, right? That's the thing that the compiler gives you, that safety. So I know we're rambling a little bit here, but again, it's all coming back to if this is your first programming language and it's a little difficult, they're not all like this. And the difficulty is because you're getting something in return. You're going to get that safety, meaning you're going to put less bugs into production, right? Because your compiler is going to catch a ton, and you get that speed and performance. If those aren't as important to you, then you have other languages for that, like JavaScript or Python, right? And then you could augment JavaScript with TypeScript to get a little more safety, right? So something cool to think about, basically, if this was tough, don't be deterred. It's tough for a reason, but keep in mind that it's much easier than doing it manually. And so borrowing can be a little tough to figure out, but once you get it, and it actually is a really nice way to kind of handhold you through that memory management process. So back to the borrowing, we talked about taking and giving back. So you give something, right? You give a value ownership to this take and give back function, and it simply returns that thing back. So it gives it ownership. You can't use it while that thing has ownership, but as soon as it gives it back, you can use it again. This is another great thing I love about Rust. It's a minor thing, but oh my gosh, is it an awesome thing to have in a language. And when you don't have it, it's really a pain. And that is implicit returns. What do I mean by that? It means the last line of the function is the return statement. It's what gets returned. It is very annoying when you don't have this. So for JavaScript, you have to have a return statement, return at the end, return at the end. It's really nice to have this because it means if everything is an expression, you can end your function in an expression and the result of that expression will be returned. I don't know how many times I've written code in JavaScript where I've had a array comprehension, or I'm doing a map or reduce or filter, and I forget to like return in reduce, forget to return the accumulator, or I forget to return something from my function, and I'm like, oh, what's happening? And I forget because I left off that return. Implicit returns are fantastic. And remember with Rust, you do it by just making it the last line and leaving off that semicolon, right? So that it actually will return that value. Because we have even if conditionals in Rust or expressions, I love that. It makes it so easy to do stuff. We also talked about a reference. So passing a reference. So here we're giving a reference to calculate length with reference. That means it's not going to take ownership. And that's why I'm still able to print len of S4 here. And I can print S4. Both will print because I don't give ownership. So I pass it to this calculate length with reference, and you'll see that is going to have to take the length and call len on it. So we're passing it S4, gets that there. Oh, and you'll see here, it's a reference. And we do s.len. If we needed the value out of it, so like let's say, for example, we got some other structure and we wanted the value, then we'd have to dereference it, right? We'd have to use the asterisk. And that's the deref trait. So I really think the borrowing is pretty cool. It's pretty intuitive. I definitely like it. Let's talk about some more stuff. Let's talk about structures. Structures are great. I think pretty normal to have something like this in a language. The cool thing about structures, though, is they're typed, right? So they're typed and they're enforced. So you can create some really cool stuff and you can model data in a really awesome way. I like these better than classes. I'm not really a fan of object-oriented programming. Don't get me wrong. Like I said, there's a right tool for a job and it definitely has its use cases. I just tend to lean more towards functional languages. I find them easier to work with. So I like that we didn't go with classes here and that we instead have structures that just describe what something looks like, and then you can create instances of them. But we're not dealing with like inheritance, and we talked about that in the object-oriented section. We're not dealing with inheritance in that sense. You can still get those benefits without directly using those, because I think those concepts can be kind of confusing and can get kind of messy. It's hard to figure out, I think, best practices when you have that kind of stuff. So I like structures. It makes it really nice to model your code. What do I mean by that? When you have some data that you want to like model or like structure, right? That's what a struct is for. It creates some structure. it not only makes it easier to think about stuff, it makes your code more readable. And this is a key thing. As engineers, as anyone developing code, if you're developing code, you're an engineer. I don't know if you know it, but you are, right? If you're developing code, a lot of time when you're working professionally with software, or even when you're working on code yourself or fixing bugs, you spend more time reading code than writing code. And so structures, besides the benefits that they give you when you're writing your code, they make your code really readable. So I know here that I'm dealing with a user, right? It's just right there. It's in my face. And the compiler is also going to say, hey, you're dealing with the user. You need to include these properties, right? Because that's what the user should have. And you can declare, okay, this property should be there. If something doesn't need to be there, you can say this property is an option, right? It's either some value or none. So structures are super, super great for modeling data. And then the other thing that I let me see if we can find it. Oh, so the tuples, like this is great. I love this. It's just easy to model data. It really is. It makes it so great. So this is a very powerful thing. I want to talk about the implementation block. Here's an example program using structs. Pretty straightforward. Let's see if I can find the part where we did an implementation block. Method syntax. This I wasn't a huge fan of, and I'm still a little iffy on it. I get it. I like it. It's pretty good, but I'm not in love with it. What do I mean by that? To me, it feels weird that the implementation block is outside the struct, if that makes sense. I know it has a reason, and it totally makes sense. And I think the main reason is that your struct can remain clean, and you can see what it is, and then you can see separately the kind of functions that it has. What's weird about it, though, for me is like the syntax. I don't know. I think it just looks a little odd. You have your struct rectangle, your implementation rectangle. And actually, let me see if I can pull this up. Let me see if we have this in our code. I know we have it somewhere. It's probably under structs. Okay, so here we have tuple structs, build user. Let's see. Oh yeah, so here's our user. So do we have structs, functions? No. Let's see, methods. Do we not have a thing on methods? Interesting. Structs. Let's see. What chapter is this? 5? We didn't start doing that yet. All right, so let's just look for this. What is this one? IMPL. There we go. It's under rectangles. Anyway, so yeah, like the syntax here was a little bit weird for me, having it be separate, like your implementation block. But it is kind of like, now that I think about it, it's not maybe as strange. Like it's nice, like you have your structure and then you have the code. But what is weird is you could put this anywhere, right? I could put this down at the bottom. Like it doesn't need to be attached. Maybe that's on purpose. I'm sure it is, but that was a little weird for me. And the reason it's a little weird because I tend to think about stuff, especially with structs, like I think about it as like a type or something like that, even though it's slightly different, right? And having functions on it, it starts to me, it makes me think of a class, right? Because we generally have like a new function for instantiating one, a can hold, and you have like your self notion. So I start thinking about a class in JavaScript, and then I think about how it's usually all grouped together, right? But I guess the benefit of separating it out is you can define it everywhere. And I'm excited to see when I look at other projects how the code is structured and where they put structs. Do structs usually get their own file? I'm excited to see that. That's the kind of stuff we don't really get to see in the book. It's something that I see all the time in other languages. You slowly figure out as you use it. What's the best practice for file structure? Where should stuff go? I'm excited to see when I look at other projects, like how do they structure their code? Where do you put the structs? Are they in the file? Are you just importing them? So that's pretty cool, and that'll be interesting to see. But yeah, this is a little weird for me. Again, just a little bit different. The other thing I struggled with for sure, and also, by the way, with any of this stuff, put some comments. If you totally disagree and you're like, Tom, you're wrong, put it down there. That's awesome. That's exactly what I want to hear. I want to hear everyone's opinions and feedback, because I'd love to hear why people like different stuff. Maybe I'm not thinking about it the right way. Or if you agree, maybe you're like, oh yeah, I also am confused by the mutable self in the method. Put it in there. All right, let's chat about it. I think it's fun. We're all learning, so. Area. So yeah, so like the fact that you get this reference to self, this makes sense to me. This is pretty clear. It's very similar to Python, right? If on Python class methods, you get self as the first argument. So not too foreign to me. But then there was like other cases, let me see, like where you get mutable self, and that's when you want to mutate something. So I like the implementation blocks because I like that you can encapsulate functionality dealing with a rectangle. But yeah, this was a little strange, and I'm still probably going to be taking a little time to get used to it. Now, let's go more in depth here. So, pattern matching. Rust fam, come on. I love pattern matching. If you didn't know this, if you didn't pick this up, if you didn't Google Elm or Elixir when I was talking about those, I was like, oh yeah, I like this language called Elixir. Huh? This is fantastic. Oh yeah, I've used Elm. It's pretty cool. I'm not just name dropping. I am just name dropping. That's a lie. I'm just name dropping. But the reason I happen to love those two languages, pattern matching. Where do I start? Pattern matching. Oh, pattern matching. Where do I begin? But really, I love pattern matching. Why? You're probably thinking, why? Why do you love pattern matching so much? Well, because it makes writing branch code or ARM code in this so easy and so readable. Now, I've worked with JavaScript for a while. I've worked with Python. You have if statements, you have switch statements. Switch statements are great when you start getting a lot of stuff, but they're not as powerful. You're just checking the value of something or checking a conditional and then doing something. With pattern matching, you can express things in the pattern. Let's go more into it. And we've been through the chapter, so you've seen it, but let's talk about it more, because I want to talk about it in the context of other languages and why I really love it, because I'm pretty stoked on this feature, and this is why I was so interested in Rust when I found out Rust had pattern matching. All right, let's take a look. So, what is pattern matching? So we talked about this IP address thing. Let me pull it up in my code. Pattern matching. Okay. Why is this cool? So, with pattern matching, it's like a conditional over a value, right? So let's look at the very basic example. Match X. We've declared X as 1. So you literally use the value here. We're not saying it's a string. We're not doing if X equals 1. You can leave off that crux and that extra boilerplate. It's just match on X. If X is 1, this ARM executes, plain and simple. If it's 2, execute this. If it's anything else, execute this. So this is equivalent to an if X equals 1, else if X equals 2, else this. But this just reads, it's simpler. But this is, we're not even touching the surface, right, of why I love this. But this is one reason, right? It makes it simpler to write this stuff. Reason number 2. This right here. This is like a beautiful thing. Here we're matching over an option, right? So if you look here, why is my Rust analyzer, is it not showing up here? What's going on? Let's see. I know why, because I'm not in the actual folder. That's why. All right, so let me see if I can do that. Yeah, let me just go into this folder. I'll open it separately. This way we get our analyzer, because it's going to be useful. So we'll do PD projects, chapter. Well, we talked about it in chapter 18, but we talked about it earlier in that too. But chapter 18, we really got to see some examples. Pattern syntax. Chapter 18 was very recently, right? But we've been using pattern matching throughout the whole book. Okay, let's download the latest version of Rust Analyzer. Also, by the way, early in the book, we didn't use Rust Analyzer. The chat was like, yo, Tom, you're a clown. You need to get on Rust Analyzer right now. And I did. And I pulled out the theme. Greyjack in the chat had his own theme, which I think it plays really nicely with Rust Analyzer. So that's the theme we're using here. Okay, so you're seeing this. That's because I'm not using it. So we're getting the compiler is actually compiling as we code, which is fantastic. This is another, let's get here in a second. We'll talk about Rust Analyzer in a second. Let's focus on pattern matching. We'll come back because this is low-key one of the best things about Rust. Okay, so here we have an option, integer 32. And what I like about this is that case, right, where you have some or none. And it makes you handle all of them. If you do a match expression, you have to handle all the arms. It's going to look at the type of the thing you're matching over and say, hey, you haven't handled this. So what I like about this is we have some. And look at this. It's like a if else, but much more readable. We're saying if there is a value and that value is 50, print got 50. Otherwise, if there is a value and it's not 50, if it's anything else, print this. Otherwise, if there's no value, print this. So this, what would this look like? This would look like if x equals 50, print this. Else if x doesn't equal 50, print this. Else print this. But the beauty here is the variable capture, right? We are capturing, here we're actually using, like, look at how we're doing this here. We have x is some 5, y is 10. So we're actually able to use y here. So let's print this out. Let's just show this one because this one's kind of cool. Matching named variables. Let's run this. Change the color to whatever, that's that one. Matched y equals 5. So what happened here? So we've declared y as 10. But here we're repopulating y with the value from x. Let me show what that looks like. So let me show you in a different way. If I were to change this to z, right? And we say z equals, comma, z equals that, and let's do y equals, and we'll print y as well. Now let's run that same code. You can see z equals 5, y equals 10. So y is not modified in this case. Y still takes the value of 10. But here, we were actually able to change y, right? We were able to change the value of y, which is cool. It's letting us not only match on something, but capture that value. That's the cool thing about it. You can't get that out of an if statement. It's not going to capture the value in the if statement. But here we can actually capture the value in a variable and then use it. We don't need to do it in our arm here and say, like, for example, if we said, something else, like let's do x, we wouldn't have to say y equals x, right? And then print it. So it lets us create variables, or in this case, we're shadowing. Why are we shadowing? Because we're changing the value of y here, right? We have let y here, and here we're just changing it. But that's awesome, right? It gives you the ability to use those. Okay, let's look at another example. Here is another example. 1 or 2. So this is, again, this is like if x equals 1 or x equals 2, print this, otherwise this. So again, this could be modeled as an else if, but it looks a lot nicer. This is another sick one. A range of values, right? You could match on a range of values. So if it's 1 through 5, print this. Otherwise, print this. So it's very nice, easy way to express what you're looking for. Here's another range, but what I'm more interested in is the stuff down here. This is another simple thing. It's pretty cool though. You can map a range, really cool stuff. But let's look at when it gets more cool and useful, and this is when you're dealing with structs and data. And I talk about Elixir a lot because Elixir does an amazing job of this, because Elixir can actually pattern match in function arguments, which is really powerful. So you get the same ability there. And I'll probably do a video on Elixir just because I've been really, really enjoying it lately. I've also been enjoying Rust, but it's what I've been coding more in, so I'll probably do something on that. But for now, I want to talk about this. So destructuring structs here. So we have a structure, right? And I love this because our structure has two things, right? It doesn't have to have two integers. In this case, we do. And we have our point, and we've created this point P, right? P equals 0.07. And then we've destructured the point, so we've captured x and y from the point. So x will be 0, y will be 7, right? And then we assert that that's the case. So we show that our destructuring works. And this is actually pattern matching. Destructuring is using pattern matching. It's basically saying the first thing in the tuple at the value x goes here, the second goes here. So that's destructuring is kind of similar, right? Okay, but here's where it gets cool. We can actually map on different values. So here we're saying we don't really care about the value of x, we just care that y is 0. And if y is 0, do this. Here we're saying we don't care about the value of y, but if x is 0, do this. And here we don't care about either. So this is like a more complicated, would be a much more complicated if statement, right? You have to say if y equals 0, do this, else if x equals 0, do this, otherwise do this. So, I mean, it's not too complicated, but it really lets us model things nicely. Also, we can use those values right in here, which is nice. Another one was down here where we have, this one is really cool. This is using a cool, like, complex structure, right? Or in this case, we're using an enum. And we're using an enum to represent possible things that we can do, right? Possible messages. And this is really cool to model your applications and model what users could do, right? And so this is a cool, like, powerful use case of the feature. So let's take a look at what we're doing here. Because, again, I know this is review and recap, but I love pattern matching, so I wanted to chat about it because it's definitely one of my favorite things about Rust. Okay, so we have our color. We have our message. And so our message has these different values. So we have quit, move, and move has to be supplied a point, it looks like, basically. Write, and write has to be supplied a string. And change color, and change color has to be supplied a color, and the colors are reflected up here. Color can be an RGB or HSV. So first we create a message called message change color, and we create that with a color 0, 1, 62, 55. That's the RGB values, right? Actually, for HSV, I'm not totally sure what HSV is. It's something hue, saturation, and value. I don't know. Anyway, look at this. We're mapping on that message. So look at how cool this looks, right? So if our message matches this, if it's a quit message, we do this. If it's a move message, we pull out X and Y. We can use them, right? We can use them right here, and we can use them. That's great. If it's right, it's going to have a string. We're not only checking if it's right, but we're pulling out the string, storing it in a variable, and then being able to use it. We're doing all of that pulling out and storing it and checking in this one little statement, this one little match. Same thing here. Check this out. We are matching on change color, and then we're pulling out the RGB values and storing them in R, G, and B for use within our function. So our match not only does the check, it does the destructuring. So it's super cool. Just makes writing the code look a lot better, in my opinion. Other stuff like this. Yeah, anyway, I can go on for days about pattern matching, but you can see how powerful it can be. Just like match guards, you can add guards, extra conditionals. So some X, if you don't want to say, if you don't want to look for a specific number, you can even add a conditional there. But again, you're still getting the benefit of pulling that value out and storing it in X. Just a really nice, guard clauses are super powerful too. They're really great because they make it, sometimes the guard clauses make it a little more readable. Here's another example message, other message, hello. Here we're doing hello, and we're pulling out the ID. Look at this, a range, right? Super cool. So yeah, so pattern matching. Anyway, to sum it up, I've already said it. Pattern matching is a huge thing that I love, and it just makes programming a lot easier, in my opinion, especially when you pair it with stuff like enums like they have here. Like our IP address. If you look, I remember our IP address, we can look at the end because I know it became pretty cool. I think it happened over here. Oh, coin. Coin was a cool one, right? We talked about the type. We matched on that. Control flow with if let. This was cool. If let was a little weird for me at first because it was like combining a conditional with creating a variable. It's almost like a pattern match outside of a match, right? So like if let sum 3 equals some value. So it's like here it's doing if sum 3 equals some value, print 3. It takes a pattern and expression separated by an equal sign. It works the same way as match, where the expression is given to the match and the pattern is its first arm. So yeah, so if it's 3, it's going to store that value, right? So that was, it's strange. I think there's a better example down here. Yeah, if let coin quarter state equal coin. So if basically it's saying coin quarter state equal coin. If this pattern matches, we're going to be able to use state, right? We're going to have access to state. So it's like pulling that pattern outside of a match. So super powerful, really cool. We talked about packages. Don't want to get too much into that. We've already talked about that a bit. The other thing I want to talk about, the collections are pretty good. The vector macro, there's a lot of things like I need to be looking up a lot, like especially like the syntax and the functions, and that's to be expected. If you're finding yourself do that too, I think that's totally to be expected. Like the difference between a string slice and the string for me was really confusing. And then you had like the string from versus the toString, and they both kind of did the same thing. That was a little bit tough for me at first. The error handling I really liked. I already talked about this. I loved the result. I liked the error handling. I think that's awesome. I loved that we could use the question mark to decide if it should panic. Unwrap, right, was another great use case where we actually just tried to do something, we unwrapped it. And I think down here we leveraged panic. Yeah, I think the error handling is great. There's a lot of different ways to do things, and that's like where I'm going to have to try to figure out what the best practice is, but that's any language, and you figure that out as you go. This was hard. I'm not going to lie. Traits, generic types, this is always tough for me. But if anyone else found this tough, I think it's kind of normal that this was difficult because it might not be something you've dealt with. But I have a lot of trouble with the syntax around traits. That's one of the things I'm definitely struggling with. What do I mean by that? Generic data types I understand, and I understand their use case. If you don't and you're new to programming, it's very hard to know when generics are useful until you've needed them. To give the most basic example I always tell people, generics are useful. This isn't the only example at all, right? They're extremely useful, but this is the simplest example I can always give people. Imagine you're a library author and you write a function that takes in a value and converts that value to a string and returns it. How does it do that? You just call toString on it. You need generics if you're the author of that because you want to write your function and you want to express that, hey, my function will take any argument that has a toString and it will call toString and return it. So you are taking a generic type as long as that generic type implements toString. And that's where traits come in, right? So it's like traits are going to express, they handle that second part. That second part that's like as long as it implements blank, as long as it has a blank function. That's what the trait is doing for us. The generic is the part that's saying, hey, this will take any type, right? Any type and return some other type. But that trait, the trait part's filling in that as long as it has this function, or as long as it has this property, as long as it can do this thing, right? And so Traits are really important because we saw the copy trait, but they let us really use generics in full power. So the syntax around this was kind of rough for me, to be honest. Like here, let me see if I can pull up. Let me just pull up our own file here. What chapter was this? 10? I think at this point I started keeping track of the chapters. So let's take a look. Chapter 10. Yeah. So, yeah. So some of this was just, it was a little rough. Not going to lie. So we started out pretty basic. This takes a list of integer 32, largest character. So we start out and we said, okay, let's write a largest function that works on an integer and a character. Let's do one individually, write them both, and then let's do one that can handle either, right? And so we went from largest integer, largest character, to a generic largest. And so this is where we need the trait and the generic to kind of explain what our function does. So largest operates on an integer, and what it's going to do is it's going to loop over that integer list, right? And it's going to find which integer is the largest. How does it do that? It's going to compare. It's going to basically keep track of the largest thing it's seen. And if it gets something larger than the largest, it makes that the new largest. So if you have, let me see what I have around my desk. Books. Okay, so I have 3 books in a list. Let's say this is the order. What largest is going to do is it's going to take a look at each book. I'm going to try to put them in the order. So this one's the largest. We're talking about height. I'm going to do height based on height. So this book, it looks at this first. It says, hey, this is the largest book I've seen because I haven't looked at these yet. So this gets marked as largest. Then looks at the second, says, oh, that's bigger. Now that book is the largest. Cool book, by the way. And then it's going to look at the next book and see if it's larger than that other book. If it's not, this one still remains the largest, and that's what's returned. So I got to show off some of my bookshelf and explain that function. All right, I'm back. So that's what that's doing. Now we have the same function that operates over a character list, and it does the exact same thing, right? It checks the size. However, the size is a little bit different when you're dealing with characters, but the thing that works on both is you can compare, right? We can do partial order, comparison. So basically, we could write a largest function. We did this. A largest function that takes something, as long as that thing is comparable, right? Its size is comparable, we can return the largest. So how do we express that? With a generic and a trait, right? And I'm actually learning a little bit more as I do this with all of you. Like as I read through it again, this is actually a really good recap, and it's becoming a little less confusing for me. So this is kind of cool. So how do we do that? How do we reflect that with a generic and a trait? So generic T, you'll see this a lot. This is just capital T. The reason this is used for generic is it's usually used to say a generic type, right? Of some type T. Of some type T. You'll hear people say that. So we take a generic type T as long as it implements the trait partial order. How did we know to use this? The book told us. No, but yeah, I mean, that is why. But we also got partial order from the prelude, so we didn't have to bring it in. But let's look it up. If we look up, we can probably find more about it. So let's look up Rust partial order. Trait for values that can be compared for a sort order. The comparison must satisfy for all A, B, and C. Asymmetry, transitivity. So the transitive property and asymmetrical, right? You can pull it in. We didn't need to do that. I think it says something about it being in the prelude. Partial order only requires implementation of partial compare method, what the others generated from default implementations. So this is how we can read about partial order. But yeah, so we have our partial order, and we're saying it just needs to implement partial order. And then our argument list is a bit different, and that's also different. Let's look. So up here, let me just copy one of these down here so we don't have to keep scrolling. Or let me just move this up. Right, it doesn't need to be here. Let me move this up a bit. Okay, so here, the difference here, we had a reference to a car list, right? Here we have a reference to a list of type T, of generics. What do we return? We return a reference to a character, the largest character, here the largest integer, here the largest of type T. We don't know, right? And then everything else in the function is the same with one caveat, this here. So at the end here, we're returning a reference to largest. Right. The other thing is here, I forget why we're starting at -1. That's the end of the list. We're starting at the end of the list in this case, which I don't know why we did that. But regardless, here's the function. And you can see it lets us do the same function with a generic type as long as that type implements partial order. So pretty cool. Right? It's going to do a comparison, so like which number is bigger, right? Which string is bigger, which character is bigger, right? And we can do that. So again, we're able to specify that by saying we support something of that type, T, as long as it has, implements, or can do trait, partial order. Type T, partial order. That's the combination for writing a function. Right, that does these kinds of things. So that was pretty cool. What I did have more trouble with though, it was not necessarily that, but it's actually when we started getting into this complexity stuff, the implementation block. This syntax was weird for me, because you have implementation block, and then you say generic type. I understand this TU, two different types, but then you say complex point, and then you have these types again. This just seems super verbose, and I don't know, it was tough. This was a little tough for me to kind of figure out why we need it both. I'll have to probably read more and see why we needed this, but I definitely struggled a little bit with this aspect of it. Because, yeah, it's still a little weird. Like, you have even in this case, let's look at this simple example. Implement T, point T. So you're implementing something for point T, I guess this here. That's this point. But why do you need this? Yeah, so this syntax was a little odd for me to see. It was a little complicated. I definitely struggle with that a bit in the beginning. I still do, right? I still struggle with that. So that's one of the things I'm not as, I guess like one of the things I'm not as fond of is the syntax. It's just not as intuitive to me coming from the languages I'm coming from. Maybe if it's your first language, it's easier, or maybe it's like unbelievably hard. Like, I'm not sure. But it's, as I use it more, again, with any language, as you use it more, it just makes more sense. But there's just some stuff. I think generally this, like here's another, it looks just craziness, right? TU, function mix-up, you also have to specify it here. Point other, here again, you're specifying it. So I think generally one of my, not frustrations, but one of the difficulties I'm having with Rust is how much more verbose it is than a scripting language. It's obviously gonna be. Scripting languages are simple by nature, but even compared to something like Elixir or Python, it's definitely more to type. It can be a little more confusing. I'm definitely struggling with remembering the syntax. I have to reference my code a lot, which is totally fine, I think. I'm not worried. I'm not holding it against myself. But the syntax can be nuts. Me like 2D in the chat said Rust has a crazy syntax. Yeah, for sure. And coming from Python, Elixir, which has a Ruby-like syntax, Python has its own syntax. Elixir has a Ruby-like syntax. JavaScript has, well, JavaScript's had many different syntax over the years. with the different ECMAScript standards. But yeah, Rust, it's definitely tough for me I can't type it from my head. I can't just go in and write a function. I have to reference my old code a lot to see how that works. There's some stuff that's really basic. Function definitions are easy, like when they're basic functions. Structures are pretty straightforward. But yeah, I often forget that syntax. Me like 2D in the chat. Thank you for stopping by. So that's one of the things I've definitely been struggling with. This chapter was really cool. I liked it because it was like talking about how to have like a workspace. That was awesome. Separating modules, super good, because generally when you learn a language, they don't teach you the patterns on how to like structure things. And then you go and you work on a project at a company, or your side project, or a project with a buddy, or an open source project. And the first thing you have to figure out is, what is the file structure? How do they navigate around? How is it structured? And I like that they presented that in the book, because like I said, some languages just don't touch upon that subject, and it can be very intimidating and very important. I remember back when I was learning a JavaScript framework at the time, Angular, one of the biggest issues from going from code base to code base was how the folders were structured. They could be significantly different based on, what team you were jumping to, or where you were writing that code. And so eventually style guides kind of came about to say, hey, it should be structured this way, and files should go here, and these functions should go here. But it took a long time to get there, and it was extremely intimidating to try to figure that out, especially when everyone was doing things differently. So it's nice that the book kind of recommends that, and Rust kind of naturally, they mentioned this too, pushes you in a certain way to handle stuff. So that's great. So yes, we started talking about this, generic traits and lifetimes. This was rough too, for me. I think lifetimes at first was tough. The syntax was weird. Again, this is another syntax thing. Like, I understand. Here, let's go to let me see if I can find the part about. Let me see if I can find it here. Like when you have this thing. No, not that. Yeah, this. This was weird for me at first. I was like, what am I looking at? But then when the book broke it down, they broke it down really well. It's definitely something where like I'm gonna mess up and not include it and then forget. But what it does is it noted. It's really cool, and it's something that I wouldn't think of from another language. But like here in this case, let's look at this content. Content is gonna take a post and return the content from a post. So here what this is saying, so we're returning a string slice, right? The lifetime is marking that the string slice will come from the post that's passed in. So we have to say, if we're actually taking a slice of something in the argument list, we need to specify that so they know not to get rid of that argument, and that argument's lifetime is tied to the lifetime of this because it's a reference. Let me break that down for you, because it's helping me by breaking it down. The lifetime basically says, okay, let's say, let me see, what do I have around me that I can use as an example? I like using physical objects. Okay. I got my Lego Reinhardt. Let's use Lego Reinhardt. If anyone ever played Overwatch, we got a little Lego Reinhardt here. All right, so Reinhardt has his hammer, right? Hammer down. That's the move. Let's say my function takes a Reinhardt and returns a hammer. In the signature, with the lifetime, you actually specify that it takes a Reinhardt and returns a hammer. And you also specify with that A, the hammer is actually part of that Reinhardt. So that argument that's coming in, I'm actually going to take a part of that, and that's going to be the hammer I return. And so why is that important? It knows that as long as this hammer is being passed around, because it's a slice, it has to keep Reinhardt around, because Reinhardt is the owner of that hammer, right? That hammer's part of him. So as long as I'm referencing and using that hanger and dragging that around, I'm dragging Reinhardt around with me. So that's kind of what that denotes, right? It says this slice is going to be sliced from this post. So you better keep that post around. Otherwise, this slice will no longer reference anything meaningful. And so it's a way to tell the compiler that, right? There you go. So it's actually pretty cool. But the syntax, like I wouldn't know looking at that, right? And so that's something that I'll have to figure out. So that's one of my things where I'm not as good with it. Structs, clear, whatever. Those are pretty straightforward. We talked about that. We don't need to talk about that anymore. Pattern match we talked about. Packages and crates. I want to just go back actually because chapter 10 was the craziest. So I just want to see what else we covered in here. Generic data types. That was pretty straightforward. We talked about points. Yep, we did that. That was kind of cool. I'm definitely going to cover this more. Traits. Defining traits. Ah, yes, this. Okay, so this actually wasn't that bad. Like once you're past the implementation block, I think declaring, summary for newsletter. The thing that is a little rough for me is I'm not good at like remembering the inner part. So like here, let me go down here. Let me show where they show some more code here. Here, let's pull it up on our end. Traits. Let's see, where do we have? That's chapter 10. Yeah. So chapter 10, traits. All right, so we have summary. It's a trait, and summary says that you have to implement, if you have the trait summary, you have to implement summarize author and summarize. Summarize author returns a string. Summarize returns a string. How does it do that? It calls format. So here it's like, here we're defining a function that just takes self and returns a string. And here we're actually saying summarize, and it's actually a function. This is the default. So that's pretty great. Mike, me like 2D in the chat said, Rust is such a powerful language, but I'm an object-oriented pleb, so I have a hard time learning other languages. Classes equals good language, 10 out of 10. That's hilarious because me like 2D, I was just saying how I'm the complete opposite. I'm a functional programming pleb. So for me, I'm like classes, but I totally get it because classes, I think functional object-oriented was what I first learned. It was much easier because our world is made up of objects, right? Cup. So it's easy for, like, I think initially to understand programs in that sense. Coming from JavaScript and Kotlin. Yeah, so JavaScript, OG JavaScript, you had prototypical inheritance, you had prototypes, then you had classes. Now JavaScript, with some of the frameworks, is leaning functional, but yeah, it's definitely like, it makes sense. Our world is made up of objects, and it makes sense to think that way. I know in video game programming, that's a huge way to think about stuff. I've been more recently enjoying the functional programming side of things, and what's cool about Rust is there's even a chapter, right? Rust has a little bit of both. So you have your object-oriented chapter, right? And then we also had our functional chapter, which was, where was that? Object-oriented. Where was that? There is a functional chapter, I promise. Well, it's somewhere. But yeah, they did a functional concepts chapter, and we had the object-oriented chapter. So it's got a little bit of both. While it doesn't directly have like inheritance and objects, classes, you can kind of make them with structs. So here we have, this is kind of like that, right? This is kind of like inheritance. So he says, I can understand the syntax. I can understand the syntax and all, but I just have a hard time structuring things. Yeah, me too, for sure. It's definitely tough. So here we have this is kind of like object-oriented. So we have summarize, we have the default, but then here we're actually saying newsletter, and we're going to implement summary for newsletter, and we're going to change it so that the summarize does something a little different. So this part's pretty easy to understand. And I think just like they said in the chat, just like me like said in the chat, it's like the structuring things. Yeah, sometimes it can be hard to kind of structure the stuff. So they made a good point there in the chat. All right, so here we like this part, I think it makes sense, right? To have summary for tweet, like you're saying what it's for and you're implementing it. But since I just forget the syntax. And then even here, trait bound syntax. This was the one I was very confused about. Trait bound syntax. I knew there was one thing I couldn't even think about what it was. The trait bound syntax was confusing for me because you have notify, your generic type, summary. I don't know. Maybe it's simpler now that I'm seeing it, but it was very complicated. Oh, here, look. Function returns implementation summary. This stuff was tough for me for sure. Returns summarizable. It returns an implementation block. Yeah, summary. Yeah, this was a little weird for me. This implements, so here again we have this crazy syntax where we're saying T has to have these two traits, display plus partial order. This is again an implementation block with a generic, that's why it looks like this, but it's just, yeah, it can be a little confusing for sure. Also this, like, if you're coming from other languages, this is like verbose, right? Having to do string from, but again, we learned why that's the case, and that's because we're not dealing with like regular strings, right? We have strings, we can string slices. So, yeah, this was, you know, a little bit more verbose, but again, you could use a string slice. It's just whether you're declaring on the stack or the heap, right? Which we also learned about. That's another cool concept. So there's a lot of things flying around, but as I use it more, I will definitely get a little better with it. But I like how the book has presented it all. They present it in a nice flowing way. Okay, another topic. I loved the way they've done tests, I must say. Let me see if I can show it here. Let's go to our chapter 11. Chapter 11, we're filing for chapter 11. No. So I love that tests just go in the file. What I don't love, like straight up, like this isn't like, I'm sure. I really don't love this stuff. It's super confusing to me. I get what it does, but like it's not intuitive to me. I don't remember these. I always forget them. I have to reference them. I don't know what this is called. Like if this thing has a name. I forget if it's like an annotation or what. I don't love this. Also like this, I get this, but yeah, I feel like there's a little bit of ceremony that I just don't get. Someone probably knows. Just put it in the comments or point me in the right direction. Maybe we did read it and I forgot, but like this stuff I always forget. Like the derive, like that syntax, kind of wacky to me. But I love add to and to. Like this I just love that it can go right in the same file. And it's just like using a straight up assertion. It's very easy. Nothing to hide there. I just like that you just put test right here. It makes it easier. It makes me want to be able to test. Also, we learned about like skipping tests and things like that. You can run them on compile. Like it's just very, very nice that they're just right in the file. I love that. And you could break it up into a different file, but I just like how easy that is. You don't need to import another library if you're using JavaScript. So MeLike2D said that they use JavaScript and Kotlin. I know for JavaScript, if you're testing, you're probably pulling in some other testing library like Jest. Jest is real popular right now. Maybe you pulled in Mocha or Jasmine or QUnit. We got Dozeboy in the chat with the hype. Welcome, Dozeboy. We're reviewing the book today, talking about what we like and don't like about Rust. So welcome. So yeah, so like I love it. Testing is super easy. You don't have to pull in any libraries. You can literally just put it in your main file. It's super easy, and it's great when testing is easy. When languages make testing easy, people write tests, which we all love, right? It could take a lot of times. It takes longer to write the test than the code, right? And debugging isn't that bad. Yeah, we haven't gotten into like much debugging. Like we haven't done any kind of debugging where we're actually stepping through the code. I do kind of want to see what that's like. MeLike2D said, I don't even do testing. I don't see a point in doing it. So yeah, I feel like with Rust, the compiler probably catches a lot, right? I think it's more for like the business logic that I would test. I would say I would write tests for functions that do some complicated business logic that I wouldn't want messed up, like maybe calculating the tax, or that's always the example I use. But generally, what's nice is because the compiler catches so much, you don't need to test things like types or stuff like that. You can actually test business logic, which is kind of cool. But yeah, I think that's fantastic. I really like the testing story that Rust has. What else did we learn about? So we did the command line program. That was super cool. Mini grep was fun. That was another thing. So the cool thing, the book had an intermission where it had us do mini grep, and that was super cool. We actually built like a little grep utility that's actually really useful. And not only that, they told us, hey, this utility is cool, but it's for play. Like if you want to actually have a real good grep utility, you can actually pull in one from a crate. But this was super cool too. Like I liked the way it was structured. We took a little break. We wrote a program to flex those muscles. And that was awesome. So that was great. Here we go. So this is me like 2D. This is what I was talking about. There's the functional chapter that we went over. Talk about the functional concepts. We talked about the object-oriented concepts. Smart pointers. This got a little crazy for me. I knew we were going to get here because this is one of the ones I want to talk about. This was tough for me. It's a difficult concept, I think. It was a little bit hard for me to get. Again, none of this stuff is like, oh, I'm never going to, like, I'm loving Rust. I'm going to continue using it. But this one tripped me up a bit. Mainly because I get why it was used. Like, it's very useful. I'm just worried that I'm going to forget when to use it. And I'm hoping the compiler will tell me, but I want to make sure I use it effectively. Specifically, the ref cell. The ref cell was like, the box I kind of get. Like, the box makes indirection. It makes sense. Ref cell was a little bit tough for me. And I'm definitely going to spend more time on this. And as I go through stuff, spend more time. Because the syntax starts getting wacky. Like, wild. Super verbose. Like, just looking at this out of context, it just looks absurd. I know what it's doing because we've done it, but like this, if I were to just be handed this, I wouldn't be able to read it. Like, if most of the time when I'm looking at another language, I can kind of figure out what it is, even if I don't know that language, just from my experience going from language to language. But if I saw this without reading the book, I would have no idea. No idea. So I think this was very difficult. And this is the part of Rust I'm like a little nervous about getting into. And like, I could see this being, if this is your first programming language, I could see this being intimidating. But again, all this stuff eases up as you use the language. But for sure, this was scary. Concurrency. It makes concurrency very easy with spawning threads. I thought that was very easy until it started until we started looking at like, sorry, I skipped. Where'd it go? Concurrency, come back. Concurrency, here. It introduced threads really nicely. So definitely really liked that. It got a little crazy when we started doing shared state concurrency, because then we started pulling in smart pointers. It got a little crazy, right? With the mutex. But again, these are very hard concepts generally. That said, there's other languages like Elixir deals with processes, I think, in my favorite way. So I definitely prefer the way they handle it. Just makes it really easy to deal with processes. But Rust does a good job with it. It's definitely a hard concept. And the thing though is, there might be more coding up front and more to understand up front, but you're getting that safety harness that you wouldn't get in something like Java, where you can have locking threads and it's preventing you from doing that stuff, which it's okay to pay that upfront cost to get those guarantees, because the last thing you want is to write a multi-threaded program that's going to lock up in production, right? So that's something we're going to revisit, but yeah, definitely intimidating. The web server was really cool. It started out great. The single thread was super easy, and then it got crazy complicated, I think. That was kind of interesting. Like, it started out very straightforward, easy. Then as soon as we started going to multi-threading, we started pulling in reference counters, creating thread pools, like this. It got a little crazy. It definitely got a little crazy. Not as simple as I thought it was going to be. I thought it was going to be like, look how easy it is to make them. It definitely wasn't. Rust in a nutshell. Yeah. So exactly. You're paying up front, but you'll get that added benefit. So overall, I think the book did a fantastic job of walking through the concepts, then introducing an exercise, then some more concepts, then an exercise. There was definitely some times when it got pretty crazy and the syntax got crazy. I think for me, what I'm going to need to spend more time is on just coding it more, like building stuff with it, referencing code, looking stuff up, leaning on the compiler. I've talked about that a lot, leaning on the compiler. It's going to give you that benefit, right? So do it, lean on it. And the book was great. I think I'm very happy. And you've heard me say this before, if you've watched the stream or you're watching on YouTube, I'm very happy I went through the book. Most of the time I dive right into a language and then learn as I go. I was recommended by friends and colleagues that, oh, with Rust, it's got a lot of complicated concepts, especially coming from JavaScript or Python. So you have to read the book. Like, they recommended reading the book first because it's got so many concepts. And I get why that was recommended, because I would have been lost. And you saw when we did Rustlings, if you were here for when we did Rustlings here, we were able to do most of it, but we had to go back to the book, and we got totally caught up on the thread part. But Rustlings was really fun. So overall, I'd say the book was awesome. Some crazy concepts. Rust makes some of them very simple. The syntax, I would say, on a scale of rating on the languages I've used, it's one of the more difficult syntaxes, I think. But with the added benefit of getting that safety that you do not get in Python, you don't get in JavaScript, not even something like Elixir. Maybe when you're using like very strict TypeScript, you get some of that, but not even close to what you get in Rust. Elm is the next closest thing I can think of in terms of compiler catching stuff. But with all that the compiler gives you, it's worth that upfront cost. Again, if you need that type of safety. With any language you pick, there's, like I said, do you enjoy using it? Does it have a good developer experience? Is it the right tool for the job? Is it overkill, or what gets you to solve your problem quicker? Because ultimately we're writing code to either have fun with it, which is the fun experience, developer experience, or to solve a problem. And so you got to always ask, will this make, is this overkill? Will it solve my problem? And in some cases, if you need type-safe code, if you need a binary that works on Mac and Linux, Windows, Rust is great. It's going to be safe. Writing low-level performance stuff, it's going to be safe. And I feel like eventually, after we start to use it, because the syntax isn't that bad, right? It's not. I think it's better than some languages, but it is a little rough at first. But I'm sure I'll get to the point where I'm writing some scripts in it for my computer, or writing some binaries. I'm hoping to employ it at work a little bit. Where currently I'm using maybe some Windows PowerShell scripts and some Mac scripts. Maybe I can write some Rust binaries instead. So I'm definitely looking forward to that. But yeah, I think I would say syntax is tough. The resources are excellent. That's the thing, right? The book, Rustlings. We might try the Rust exorcism, but there's so many Rust resources that learning it, and they're free, right? This book was free. So again, shout out. Thank you to Steve Klobnik, Carol Nichols, anyone from the Rust community. The resources are great. Learning resources are great. The community has been great. So that's a huge plus. Performance, the compiler is fantastic. The compiler messages are best in class. The only one I'd say it basically is maybe could be better, could be equal, would be the Elm compiler. The Elm compiler, if anyone has ever seen it or heard me talk about it, the Elm compiler is far and away my favorite, but this is right there. And I think they took a lot of hints from that and vice versa. I think they both kind of maybe took influence each other. So I love the compiler, loving that. So basically, my overall impression after going through the book, I really enjoy Rust. I think for a systems programming language, it's extremely accessible. Would it be my first language to learn as a programmer? No, I would say definitely not. If it is your first language, don't be deterred by me saying that. It's just having done other languages and coming from them, it's more difficult for me. It's kind of like when I started with snowboarding and then I tried skiing. Skiing was hard, but I've heard from everybody else skiing's easier to learn. Might be like that, but I would say if you're just a very new programmer, I would think a more accessible language like Python would be the right choice. I personally love JavaScript, so I always like to push for JavaScript because it's very accessible. It's in the browser, so that's always my first choice for languages. This would not be my first choice, but for a systems programming language, again, and that's an important, I think, distinction to make. You have your scripting languages for writing quick scripts. You can write servers, things like that. And then you have your systems programming languages. Faster, more performant. You can still write the other stuff like web servers and things like that, but they have like a different use case. Rust would be the one I would use. I would use Rust over C for sure. I've struggled with C. I'm trying to think of some other systems programming languages I've used. No, that's really it, just C. Yeah, I know there's some other ones like Crystal. I think Crystal is a newer language that is C-like with Ruby S syntax, I believe. Crystal syntax heavily inspired by Ruby. Yep. So this is another cool. Maybe we'll take a look at this one day. That'd be kind of cool. But yeah, for a systems programming language, this is the one I would learn. The community is great. Cargo is fantastic. The tooling is tremendous. So once I get past that syntax, which comes with just doing more code, I'm excited. So that's kind of my take so far on Rust. I've been really enjoying it. Again, I'm going to continue with it. Sorry, I'm like clicking around. I'm going to continue with it. But my overall review, to sum it all up, amazing developer tooling, amazing compiler, amazing learning resources, super fun to go through the book and the exercises. I love how simple it makes memory management, and the compiler catches everything. The testing is super easy, very low lift, no libraries needed to be included. You just have it all built in. Cargo handles everything for you out of the box. We didn't even talk about one of my favorite parts. Rust Analyzer is incredible. What you get from Rust Analyzer, where it compiles the code as you're typing, you get the messages in line, you can see the types. Rust Analyzer is absolutely awesome. So the developer tooling is amazing. Performance is amazing. What I still struggle with the language is some of the concepts are a little bit more difficult because we're thinking about memory, we're thinking about ownership. While it does make some of that easier than other systems programming languages, coming from scripting languages or other languages like Python, JavaScript, Elixir, it's a little more difficult, but I'm getting there, I'm learning it. And then my other thing would be the syntax can be difficult to look at and read initially, coming from other languages. I'm hoping that gets better over time, but sometimes the syntax can be very verbose, especially as you start to add indirection and smart pointers, reference counters, boxes, those kinds of things. It can get kind of wild. But again, with great power, sometimes comes intense syntax. No, that's not a saying. But love Rust. I'm going to keep going with it. I hope you enjoyed this review. I know we kind of took a break from the code, but I kind of wanted to get my thoughts out. I know I've been talking throughout the book, but I wanted to get kind of like a overall summary of the experience so far. But I'd love to hear what your experience has been. So feel free to put comments in the chat if you're here on Twitch. If not, put some comments down below on the YouTube video if you're watching that. I really want to hear feedback from all of you, what you've liked about Rust. If you've been learning it along with me, I'd love to see those comments. If it's your first language, I'd love to hear what your experience has been there. If you're coming from other languages, again, any kind of experience you've had, would love to hear it. Put it in the comments or put it in the chat. Just been like really great going through it, and I'm happy to be able to sum it all up, at least my experience. But again, we're going to keep going with it, build some more stuff, and we might do some other stuff. We got Kiwi Gamer Romania in the chat. Hello, what up? We are coming to the end close here, but don't worry, if you missed it, all of this gets posted up on YouTube above, which brings me to the wrap up. So here, again, everything's posted here. Put some comments. Tell me what you think, what you thought about Rust. I want to hear everyone else what they thought. If you followed in the journey, leave comments. We've been getting some great comments. You can follow it all here. But yeah, so that's it for tonight. That's my summary of going through the Rust book. That's what I enjoyed, kind of my review. I hope you all enjoyed it, and we're going to keep going. We're going to keep going with Rust. Maybe we'll do some other stuff. You've heard me talk about Elixir and Python, JavaScript. We'll do more of that as well. I think probably as a channel, we'll do more general programming. We've been Rust focused for a while, and we'll continue doing Rust. But as a generalist programmer, we'll be doing a bunch of different stuff. So I hope you stick around. We'll be back next week with some new stuff. But yeah. That's it for tonight. Again, check out the YouTube and Twitter for these videos. If you're watching on YouTube, subscribe and like, and you'll get notified for when we post more videos. But that's it for tonight. Again, I'm Tom McGurl. I hope you enjoyed the Learn Rust live stream, and I hope you enjoyed my take on Rust. Again, if you put some stuff in the comments, be like, Tom, you're wrong about this, you're right about this, whatever. I want to hear it. But that's all. Thanks for stopping by, and have a good night. Later, Doze Boy.